Very much, Jason, for inviting me for this santai-santai talk lah. Okay, I think some of you guys here pun have some of you guys also have went to some of my workshop lah kan juga. So today, just like I will discuss more on the data analysis using SPSS and the smart PLS lah. Okay, so most of my research will be more on the survey kind of research lah. Okay, survey questionnaires, and so I will discuss more on that lah, and I will discuss some of the static analysis that in terms of that can be done in research lah also lah. Okay. So mostly I will conduct like my workshop, and it will take like 2 days. For example, like for SPSS, and I give a lot of like trainings, okay, hands-on training lah, what to click and so on. Okay, even for example, like for my smart PLS, it also take me about two days lah. But today just briefly lah, I will discuss on a little bit of the introduction lah, about these two kind of software program lah. So I will talk about some of the basics quantitative data lah, analysis using SPSS, and I will also talk a little bit of smart PLS lah. And if you compare among these two program, software program, so the first one will be what we call like the first generation lah. Okay, so SPSS is the first generation, and the structure equation model is the second generation lah. And the second generations will be much more to me, it's like for example, like using smart PLS, it's more easily to use lah, okay, compared to other software program lah. SPSS, of course, we have used it for many years back, about what 20 years, like that, 20 over years lah, I'm using SPSS. And of course, it's still the same thing lah. You have to run analysis one by one lah. For the smart PLS, it can run simultaneously lah. So that's how powerful of this program lah. Okay, so if you look at the generation, the first generation technique like cluster analysis, like multidimensional scaling, okay, exploratory factor analysis, variant logistic regression, multiple regression, and confirmatory factor analysis. So that's the first generation. Second generation is the it's a partially square structure model, and also the CB-SEM, covariance-based structuration modeling lah. So I will get back to this lah, okay, this smart PLS lah, and I will talk more on so today I will discuss more on the common method variance, okay, the EFA, Varimax versus Promax flotation, reliability, prescriptive statistics, correlation, and regression lah. Okay, that's the most basics analysis lah. And oh my God. And for the smart PLS, I will discuss on the measurement models and also the assessment of the structure model. So that's the most basic to test in terms of the relationship between the independent and dependent variables. So today, just like I will discuss some of the issues, okay, in terms of and what are the remedy, okay, for this, if there is any issues in terms of the analysis part. Macam slow sikit. Okay, so here are some of the samples, okay, that you guys can look at it in terms of this one. That can refer to your, especially your research questions and research objective, and whether your research question will be using which kind of statistics or analysis that you need to perform. Okay, so for example, like if you look at the actually this by Palin, exploring relationships. For example, like what is the relationship between gender and dropout rates from therapy? So here, if the data is not normal, of course, researchers can use this non-parametrics alternative, the chi-square. Based on this analysis, you look at your independent and dependent variable. Okay, I think all of you you know what is independent, what's dependent variable, kan? Your IV and your dependent variable, okay, and what is categorical data and continuous data, kan? So categorical data that you will label like 1, 2, male, female, gender, high and old and young, okay. Categorical like your the scale, like interval scale, ordinal scale, like that, like a scale like that. So that's for categorical, right? So if you look at for this, if the question, example of question like what is the relationship between gender and dropout rate from therapy? So your independent is categorical, like male, female, and dependent variables. It's a categorical variable dropout, yes or no. Okay, so that will be you can use this chi-square. In terms of if you want to test the relationship between like age and optimism scores, you can use like this Pearson product moment correlations. So you can test also among the independent variables, the two continuous variables, for example, like age, optimism score. So whether there's any correlation between these two variables. The partial correlations, after controlling for the effect of socially desirable responding bias, so is there still a relationship between optimism and life satisfaction? So you are testing the relationship between the two continuous variables in your independent variables, okay, like optimism, life satisfaction scores on a social desirability scale. So you will test in terms of it, whether any relationship between correlation. We say correlation between these three variables, two or three variables. It can be more variables also. Multiple regression. it will be testing in terms of the relationship between multiple independent variables, and of course for SPSS, you only it's only allowed you to test one dependent variables. So it's not like the second generation where you can test as many variables as you want. Okay, for example, if you have 3 dependent variables, you can test directly, okay, simultaneously. So so that's the difference between the first generation and the second generation. But later on, I will show you guys some of the a few of the steps, okay, just hands-on, okay, and in how SPSS be how multi-regression will be performed, okay, using SPSS. I will talk about fact analysis again later on. Okay. For example, comparing groups. Okay, for example, like for those doing like experiments, can also use the this analysis. For example, like t-tests. Okay, is there a change in participant anxiety scores from time 1 to time 2? So researchers can use the t-tests, your independent variables, like one categorical independent variables, 2 levels, and then your dependent variable, one continuous dependent variable, for example, like anxiety scores. Others analysis, for example, like let's say if your research question, is there a difference in optimism scores for people who are under 35, 36, 49s, and 50s above. So here you can use, first you need to look at your independent variable, one categorical independent variables, but you have 3 groups or more. For example, like age group, like 35, 36, 49s, and 50 plus. But you need to dummy this group, this age group. And your one continuous dependent variables anxiety score. So you can use this one way between groups Anova. The 2-way repeated measures Anova. If your research question is there a change in a participant anxiety score from time 1, time 2, and time 3? So if you look at your independent variables, one categorical independent variables, but you have 3 or more levels, time 1, time 2, and time 3. And one continuous dependent variable, anxiety score. Another one here, the 2 between groups Anova. So if you look at the question, is there a difference in optimism score for male and female who are under 35, 36, to 49s and 50 plus? And if you look at your independent variable, the 2 categorical independent variables, like 2 or more levels, like group, and your dependent variable will be a continuous data, optimism score. And another one here, the mix within Anova. For example, like if you look at the questions, research question, which interventions, math skills, confidence building is more effective in reducing participant fear of statistics, measured across 3 time periods. So if you look at the independent variables, 1 between groups, independent variables, 2 or more levels, 1 within groups, independent variables, 2 or more levels, and the type of intervention time. And the continuous, the dependent variable will be fear of statistic test scores. Okay, so here are some of the statistical techniques, okay, analysis that can be used in, but reflects your berkait dengan your reflect your research questions. Kasih besar ini. Oh, this one clear kan this one. Okay, I will talk about common method bias lah. Okay, so of course before when we start to analyze our data, okay, we need to actually clean our data to make sure that there's no error lah. Okay, so you need to check for errors, especially for survey questionnaire. Okay, survey research. So you need to check the errors. Okay, finding the errors in the data and correcting the errors in the data lah. So that's the first thing that you need to perform lah. So because let's say that you have mistakenly key in okay, the scores of the values of that any of that respondents lah. Okay. You might end up with the analysis will be a bit like something like what you put like garbage in and garbage out kan. Okay, something like it will also affect the result. So that's why you need to check when you, especially for doing this survey research lah. And there's a few ways lah in terms of how to shortcut lah. Okay, in terms of to detect the errors. For example, like if your data is like 100 or 200 of data, okay, I think that will be easy for us to just use our eye lah, to check whether there's any errors and others that you can use this like this method. Using an analyze script and then look for cases like for example like the highest and the lowest. So here it can, let's say for your we can use it through outliers. Okay, so here we can detect in terms of let's say if your the scale of 1 to 5, so maximum will be 5 lah kan. Okay, so let's say if like more than 5, then you have mistakenly key in, okay, that the respondent's answer lah. So this is the thing that you need to perform, okay, data cleaning, if to make sure that the data works well and. Okay, so here are some of journals they are required for the authors, okay, to report the common method bias if there's any issues or not. So especially for this survey research, okay, questionnaires. For example, like when you collect from single sources, okay, normally we will collect like a single source, okay. Others that collect like they have two different sources. For example, like the independent variables will be answered by the employees, and then the dependent variable will be answered by the managers, okay, for example. So that's with that kind of research, there's no need to analyze this common method bias lah. But if you look at the definitions of this common method bias, common method bias refers to the amount of spurious covariance shared between independent and dependent variables that are measured at the same point in time, such as like in a cross-sectional survey using the same instrument, such as a questionnaire. So in some cases, the phenomenon under investigation may not be adequately separated from measurement artifacts. Standard statistical tests are available to test the common method bias. So normally we will test using these Harmonic single factors, but this type of test has been criticized, okay, which is not like which cannot detect common method bias, and in fact, other researchers propose that you need to have a marker variable, okay, to test marker variable technique. So normally, this common method bias actually to detect in terms of whether your data have no issues on that. So normally, like we look at the whether that your respondent, okay, answer honestly atau tidak lah, okay. So because sometimes some of them yang just hantam-hantam only kan, just key in, okay, the answer, okay. So and that will create issues in terms of let's say that if the respondent answer from 1 to 5, so they will answer all 5, okay, from your independent variables, questionnaires until your dependent variables. So when they answer all 5, all 4, and there's no variation, okay, so this will affect okay, in terms of this common method bias, and it also will lead to multicollinearities, okay, and others. This is my experience, okay, and I did think there are 4 or 5 of my MBA students, I think about 7 years ago, and they have doing the research on something on hotel employees. So when I look at the data, it cannot run. Even like using SPSS, also it doesn't cannot perform like factor analysis. It cannot perform all these kind of validity tests and reliability tests. Similar also with like using the SPAT PLS. So, but when I look at the data, most of the employees and the respondent answer, there's no variation. It's like all 4, all 5, all 3, and so on. So that's bring up the issues, okay, of common method bias. Okay, this bias can be potentially avoided if the independent variables and dependent variables are measured at different points in time. So, for example, like using a longitudinal survey design, or with these variables are measured using different methods. For example, like computerized recording of dependent variables versus a questionnaire-based self-weighting of independent variables. If you look at common method variance need to be examined when data are collected by self-reported questionnaires, as I mentioned earlier, and particularly both predictor and criterions are both 10 from the same person. So if it's not from the same person, then there's no issues of like you don't need to test this common method bias. Okay? The only thing that you need to test your predictor and your dependent variables obtained from the same person. Okay, respondent. Okay, in terms of how to control, okay, for this method bias, one way is to statistical control for the effect of method bias after the data have been gathered. So that is to minimize the effect through the careful design of the study procedures. So that's why before we start with data collection, especially for conducting this survey research questionnaires, we need to do a pre-test among 10 or 15 people, okay, and to test whether they can understand the questionnaires, that the instructions, and so on. Okay, so and if there is no issues of that during your pilot test, and then we can start to do your data collection. Okay, to check on this common method, there are two types that there are two that we can test. We can use this Harmonic single factors. Of course, it's been criticized, and this Lindell and Whitney method. Okay, so if you look at the Harmonic single factors, you have to run this. Okay, you have to run your independent variables, your dependent variables, all of the variables, and then check in terms of the variances. Okay, the total variance here shouldn't be more than 50%. Okay, so so make sure that it doesn't reach 50% of the first component. Okay, for the first component. So to do that, we can use like SPSS. So so here are my I will test for method bias my IVs and my DVs. So here I can click and analyze dimension of reductions and factor. So here is the my variables. Okay, and I will select the variables that I will test for that for the common method bias using Harmonic single factors. Lain juga kalau duduk-duduknya. Okay kah kamu? Are you guys okay?
Okay, okay.
Macam keras kalau duduk dia nih. Biasa apa tuh? I will conduct in the lab and so on. So there's a lot of movement. So this one macam a bit static lah kan. Oh, ada my Sifu also here. He can also apa tuh? He's good on static R and so on lah. Forecasting semua lah. And Dr. Raina kan?
Ya.
Forecasting semua tuh dia yang paling hebat lah. Itu 71 tuh dah. Okay, for example, like this is my the variable test common method bias, and of course, if you conduct the survey questionnaires research, you need to perform this. If not, then you can detect. Although you recheck your data, you reclean your data, but need to check whether, in terms of whether there's any issues of this common method bias. Bila ada issue this kind of thing kan, it will affect your the result of your study. That's the if it's like if the variance is too much, it's more than 50, 60, 70%, then there will be a multicollinearity issues. So here I just like test on the independent variables. So I will shift all the variables here and I just click OK lah. So I'll click on the total variance, explain. So make sure lah kan, the percentage of this variance for the first component doesn't reach more than 50%. Okay. So let's say lah, okay, let's say lah, kalau lah kan, let's say if you have if the percentage is more than 50%, what you can do is try to look at your database, check database balik, okay, check your database, okay, make sure that if any of your respondent answer all the same, okay, like for example, like here 5, 5, 5, 5, 5, 5, or 4, 4, 4, and so on. Kan? So you need to check your data. So if it's like you can delete, remove them, okay, remove all that answer all like all 5 and so on, and you have to pray lah kan, harap-harap your data the percentage will be reduced lah, okay. So that's what I recommend with others, some of the students that having these issues, okay. Then it works lah, okay. And of course you have to remove lah, okay, that those respondent answer all the same, okay, like 5 or 4, 3, there's no variation and so on. Okay. So that can reduce your what you call here if you have the total variance like more than 50%. Okay. Okay. Another this for Harman single factors, and it's very easy to analyze using this method lah. Okay, another thing that we can that is being suggested, okay, even by all the gurus, okay, is by using this this marker variable. So this is done by employing a theoretically unrelated construct, marker variable, to adjust the correlation among the principal construct. So the question when we use for this marker variable is not related to your study, okay? It's unrelated construct, okay? So this to make sure that of course when respondent answer this marker variable from strongly disagree to disagree, of course all of them will end up answer didn't agree, kan? Didn't disagree, they are disagree lah, okay? So of course, like then you will know lah, okay? Your respondent answer it honestly lah. Okay, there are several methods, okay, that we can test using this the marker variable. So we can test correlation between any of the principal construct and your dependent variable, and then you include your marker variables, okay, in your when you test for correlation lah. So make sure that it doesn't reach more than 0.3 lah. Okay, for example, like this, the result, abuse communications. If you look abuse with the marker variable, so there's no the value doesn't reach more than 0.3. Communication also the same thing, impact also the same thing, and this the marker, okay. But, so this the marker, okay, which is unrelated construct, okay. And the question will be not are not in line with your study, okay. It's just like we can use marker variables hold on. Like the question again. Hold on. What's the marker variable there? Hold on. Okay, so actually we can use like social desirability scales. Okay, you can choose like 3 of these question from Fishes and Fick. Okay, it's a shortened version of social desirability scale. And for example, like I like to gossip at time. There have been occasion when I took advantage. Okay, and I so these 3 items from here lah. Okay, and we test. Kan kita test sama ada dia ada effect or not. Okay, in this this scale. Okay, so of course like but it doesn't related to your it doesn't relates to your study lah. Okay, so this like we can use this kind of marker variables, and we can also look at others other researchers how where they have adopted the question for marker lah. Okay, marker variable lah. Okay, so so this how we can test using the correlation analysis, and okay, another one here. Look at the principal construct intercorrelation using the correlation matrix. So if any correlations like more than 0.9, and there's evidence of common method bias. So 0.9 also it will lead to multicollinearity. So which means that the among the construct kan dia ada highly correlated. It's supposed to be not highly correlated lah kan, with if compare among the other construct lah, okay, of your study variables there. So we test, okay, make sure that it doesn't reach of 0. I think to me it's 0.8. So if you look at this satisfaction, it's also highly correlated with trust. Okay. So here it mentioned about 0.9 lah, based on Bergozzi et al. 1991. So this one should be much better lah. Okay, for example, if you look at here, there's no really more than 0.8 or 0.9 lah, in terms of correlation. Okay, another things that we look at the when we look at the marker variables is to test, to look at the R square. So make sure the R square, let's say IV and DV R square, the total variance of the dependent variable that has been explained by that can be explained by the independent variable here about 65 cent lah. So when you perform this marker variable, okay, you can like regress it to your dependent variables or regress and also regress to your IV lah. So make sure that the R square, when you include this marker variable, it cannot be more than 10% lah. So if there's more than 10%, then you have a problem of common method bias. Then what you need to do to go back and then check your data lah. Okay, so if you can remove that question, that respondent answer all completely, like 5, 4, okay, there's no variation, but delete them. Hopefully you can reduce this common method, like solve your common method bias. Okay, so that's like the issues. Others like missing value, you need to detect on your missing, if you have a missing data lah. And so there's a way also how to solve this missing data lah. Okay, now we go to this what we call the goodness of measures lah. So first for SPSS, okay, when we use SPSS for survey questionnaire research, we need to perform this two type of validity lah, kan? The validity and desirability lah. So of course, like we need to perform this factor analysis lah. So the purpose of using factor analysis is to summarize pattern of correlation among observed variable to reduce a large number of observed variable to a smaller number of factors, and to provide operational definition for an underlying process by using observed variables to test a theoretical about the nature of the underlying process. So for example, like you have 30 variables here. So when you perform factor analysis, hopefully, for example, here I conceptualized the there will be a 6 variables construct, okay, when performing this the factor analysis, okay. No social, EB, satisfaction, and loyalty. So of course that even though that we have adopted or adapted the questionnaires from previous researchers, of course we still need to perform this the validity and desirability of that all of the variables done. Okay, so when we perform a factor analysis, hopefully that it will turn out, it will generate the same thing as what you conceptualize lah. Okay, so for example here about 30 items. So hopefully it will be produce the same. Produce the same 6 construct lah. Okay. So kalau dia lari sikit lari sana, then you have an issues in terms of the validity and so on. So that's why we need to be more careful in terms of when you design, okay, your survey questionnaires lah. So make sure that you need to spend more time in terms of looking at the questionnaires whether it represent, okay, the construct lah, because so this is what we call variables. So this is like the latent variables, okay, latent variables. Okay, for example, so I rename. So normally for okay, so this is what we call latent variables, and this is your proxy. So this proxy will be the indicators. So indicators will be representing the functional. Okay, for example, that construct latent variables. So this is what we call observed variable or the proxy. Okay, proxy of this of the latent construct. Okay, when you perform a factor analysis, so the EFA is often used in the early stages of the research to gather information about explore and the interrelationship among set of variables. And confirmatory factor analysis is complex and sophisticated set of techniques used later in the research process to test and confirm specific hypotheses or theories lah. So normally for SPSS we can use EFA, and we also can use confirm. We try to confirm how many factors that should be that we should generate lah. Okay. Okay. So here are the guideline. Okay, in terms of when we look at whether your factor analysis will be adequate. I think most of you guys have already have come across this, like those researchers like doing on your doing in your field, okay, that you might come across with, like they will that researchers conduct this fact analysis. So, but what we need to look at is like the assumption that that being forwarded by CH, okay, at all. And so the KMO, the Kayer, Mayer, Auckland measure should be more than, to me, is 0.8. Okay, 0.5 is quite still very poor. 70, I think, to me, it's also very still not really appropriate. So at least 0.8. The Bartlett test must be significant. Anti-image must be more than 0.5. Commonalities must be more than 0.5. And the loadings should be based on the sample size, okay. And the factor with eigenvalues greater than 1 are considered significant, and the percentage variance expense should be more than 60%. And you need to look at no cross-loaded. If there's no the no cross-loaded between items and items with other variables. So this will be the guideline, okay, in terms of when you look at to finalize the result of your fact analysis. And so this is your sample size. Okay, based on sample size, that you will determine how much the factor loading to test, okay, for the fact analysis of your study. Let's say that if you have 250 data samples, then factor loading will be 0.35. Data with 150 also factor loading will be 0.45. So SPSS, there is even sample size matter also. Kita tidak boleh apa tu, for example, like even like for this factor analysis kan, if the sample size little, okay, it doesn't give you a good result also, because normally that sample size that we need to, let's say you have 40 questions, 40 questions, your independent variables to your dependent variables, kalau ada 40 soalan, then you have to time 10. So you need at least 400 to run this fact analysis and the rest of the analysis. And the minimum is time 5. So I think 2 weeks ago we have a seminar on the saturation models, and also most of the prominent punya gurus also highlight a sample size. So I have also experienced this with other my PhD students, okay, and my master students. For those that collected data like less than 130, 140, it doesn't give you a good result. It will, but some research, okay, they cannot, doing the survey questionnaires, some also researchers ataupun candidates PhD candidates, they only can collect like 100, 90, 100 data, especially for their target respondent are managers. Itu yang paling susah, especially for small SMEs and all that. Okay, so at the end, even like it will take like 1 year to collect 90 data or 100 data. So it doesn't give you a good good result. If there will be, if there's more additional more of that sample, okay, it can push also. Okay, it will provide. It can give you a good result also. But that's the thing, like, okay. So when even like as I mentioned just now, sample size also doesn't matter. Even like for PLS, PLS it doesn't. So even like PLS also, it doesn't. They say that you can collect small sample size, but at least you should have more. Like 180, 200 should be good enough also. Okay, the KMO should be 0.7, no 0.8 here, so you can look at here also. But lead test must be significant, and anti-image. You need to use your own eye to look at the diagonal, the small capital A here. So make sure that all the items should be more than 0.5. Let's say that there's one item here that less than 0.5, then there will be an issue in terms of the durability of that construct. So, but we can take note of it before we start to remove items for those young items not adequate. Communities, you need to look at here that communities should be more than 0.5. So if there's item that more than less than 0.5, then it's the candidate for to remove it. Communities indicate how much variance in each model is explained by the analysis. Here are the eigenvalues if we take to determine the components. So here, if you look at the eigenvalues, there are 4 factors that more than 1. Okay, so this factor should be significant, but then you need to check the total variance here must be more than 10 also. Okay, so cumulative percent should be below 50%, usually around 60% or higher. Okay, so if it's kalau sini lower kan, and there will be issues in terms of the durability okay, of the construct. So factor had an eigenvalue of 6.25 and explained 31.25% of the total variance. That's how we explain it. Okay, so here another things that the issues in terms of cross-loaded. So that's why kadang-kadang kita punya question kan, dia ada seakan-akan sama kan, it's almost the same as the other construct. Okay, so that's why and it's depend also dia bergantung juga, depend on how your respondent perceive, okay, how they the level of what they believe, okay, or they understand, okay, their knowledge, okay, about that constructs that you are that being measured. Okay, so that's why kan it will be end up with other factors. For example, like this should be social here. It end up this item kan, this one item end up in the symbolic factors. So for example, emotional here also. Here number 2, emotional. Also, this item is cross-loaded with this item here. Okay, so for factor analysis, we need to clean. Okay, so make sure that there is no items is or are not correlated, no cross-loaded with other factors. So you need to clean. Okay, so even like that's why like if you compare to the statistical models, okay, to test on the validity, okay, I think fact analysis will be the hardest analysis that researchers need to not the hardest lah, but it's a bit when I did my PhDs and my research data, okay, I have no problem with this kind of like this factorizations lah. But in other research, when they try to combine all the independent variable, the result is horrible lah. So that's why like some researchers will stop, like they cannot perform using SPSS lah, but they can run their data through other statistical program lah, like Amos or even Smart PLS lah. So ini yang paling critical lah. But to me it's like a jigsaw, it's a playing game lah. Which one that you need to remove one by one lah. Okay, just a quick one lah. Yeah, just a quick example lah. I run analyze dimension of reduction factors, and I run here. I will here. Continue rotation. Even rotation, you can choose whether using Promax and direct oblivion. But for me, I like to use this Promax. Promax doesn't remove too much data compared to the direct oblivion lah. Wih, sampai pukul berapa tu dah? Jam. Iya. Okay, so this is the quick one. Okay, all here should be more 0.9. Bartlett test should be significant. Anti-image, all of here should be more than 0.5. Total variance, communities, there's one here that less than 0.5. And we look at the total variance here. So here I don't have any issues of common beta bias. Totals 60%, cumulative 60%. So this data should be fine. And these factors generate with values that we have 1, 2, 3, 4, 5, 6. So there are 6 factors that are being generated from this factorizations. Okay, so it's also as what I predicted lah. So there are 6 components lah. Okay. So here I have one. Okay, for example here it's loaded, so I have to remove. And then I will run again. So I have another one here. So under EB pleasure. So I remove it and I will run again. So the factors nampak cantik lah, okay? So there's no cross loaded again lah. But then I will go back my the guideline, okay? Just to recheck again whether I have fulfilled the recommendation by here lah. Okay? So I go back to my data. Chemo looks fine. Okay, looks good. Anti-image also. I don't have any issues of anti-image. Looking at diagonal, this capital small letter A. Communities, I have one issue here that is less than 0.5. less than 0.4 or something like that. So which one is it? FB remove. So this is another candidate that I want to remove it lah. So I go back here. I will FB remove. So hopefully that will be my final. Oh, I have another one here lah. So pop up this one items that cross-loaded with the other item here lah. So I will remove this EB field section lah. So this will be my final result lah. So once you have test this the validity lah, we call it the how to discriminate. Dia ini ada satu what we call how we can differentiate among other factor other construct. Dia boleh membezakan lah. Okay? So there's no other cross-loaded with other item. So once you have finalized your factorialization, then we can test durability lah. So reliability, I just go test here using scale, scale and then reliability. So I will test just one of it lah here. Loyalty. So here I will choose the one that remain lah. Okay, the one that being deleted kan. You don't need to include in the further analysis lah. Kita tetap perlu masukkan lagi kan for further analysis. So loyalty here, loyalty. So here 6 but here 1, 2, 3 recommend friends positive repeat continue. So I have to delete this loyalty first, I guess. Yeah, so items here. So check on the click statistics. So normally I will tick all these items, scale and scale. If item deleted, so here and then press OK. And so this will be the combo alpha for this construct. Okay, 0.855. So normally combo alpha will be the range of 0.7 to and 0.8 or 9, okay, for combo alpha. And less than 0.7 will be unreliable, okay. So that's the difference between the first generation. So you have to do it manually. Every step that you need to run using this SPSS have to perform it manually. Okay, from factorialization and then factorialization reliability analysis, and you have to run it manually also. Okay, so once you have check all of your construct, okay, reliability of the construct, then we can proceed for other analysis like correlation, regression, and so on. Okay, so and to do that, you need to total up, okay, the score, or you need to mean score, okay, this data, these items, in order to test for regressions and the rest of the analysis lah. Manually juga, okay. So here mana ada. Okay, reliability analysis. After you have performed your factor analysis, then you need to test your reliability lah. So the ability of measure to produce consistent result when the same entities are measured lah. So normally here, for SPSS, the only choice that you have to test the reliability is by using combo alpha lah. For such a question model, you still can use like composite reliability, which is more highly recommended, okay, and to test But here for SPSS, the only option is the comba alpha lah. So if you look at the comba alpha, 0.6 is considered very poor. So it should be 0.7 is considered acceptable, but for exploratory study, if the study is already well established, okay, the measurement is well established, then the reliability should be more than 0.8. So after to perform the next analysis and what you need to do is to compute the mean score for each of the dimension. So computing so you need to compute, okay, your the items which that you have that being generated from fact analysis lah. Once you have done this, then you can proceed for other analysis, especially for this survey research land. So I just perform. Okay, I will click transform, compute variables. So this to and I will type on that construct. So here I will click on the statistical, and I use mean to compute this the construct, okay, the items of the construct. And later on, I will discuss in terms of this the issues of like using this mean or median, okay, median score or total score. So here so this is like how you compute like friends recommend. Okay, so then and press OK lah. So you have compute lah. The F1 comma kah. So if you look at my database, I have already built this construct lah. Okay. So this what you need to do lah in order to perform, okay, your regressions, your correlation, and so on. And I have already put it here lah. Recompute for symbolic, functional, social, emotional satisfaction, and loyalty here lah. Okay. Okay. Once you have already compute your variables to mean score, then you can test like the mean and standard deviation, and that's a very straightforward, okay. You need to look at if you can compare among 1 to 5. Let's say if you like a scale 1 to 5, then you can make sure that it should be at least above the 3 lah. If it's like less than 3, then your respondent answer will be more toward disagree lah. Okay, so you can look at your mean score lah and standard deviation. Okay, another thing that that you can test is to test the correlation. So we can use this Pearson correlation to examine the strength of the direction of the relationship between all of the construct in the study. So Pearson correlation coefficient can vary from -1 to +1. So here are the we can use Cohen 1988 to interpret the correlation. So whether your relationships, your independent variables have a correlation with your dependent variables, or you can test among the your independent variables, whether there is any relationship, whether there's any correlation or not. So here are the values that you can determine in terms of whether it's small, weak, or strong. Small, weak, moderate, and strong. So, for example, like 10 to 29 will point to will be weak correlation. Moderate will be negative 30 to negative 0.49 or positive 30 to 0.49. The strong relationship will be more than 50 to 1.0, but we cannot have the correlation value more than 0.8. 0.8 here. So correlation is to test between relationship between your among of your independent variables and your dependent variables. So a very quick one here. So I click on analyze. Correlata and click on bivariate. So so this were IVs, okay, and okay, symbolic, functional, social, emotionals, and correlation using the test of significance tell or test whether it's positive or negative for this correlation. So when we test, just click OK. So this will be that. So it's a mirror image so we can read it like from here and downward like symbolic. The relationship between symbolics and functional 0.351 will be moderate. Symbolic and social is quite a bit higher for 0.550. So we read it like this. Okay, symbolic to emotionals, symbolic to satisfaction and loyalty. So if your objective is to test the relationship between the independent variables and with the dependent variables, so you can determine here in terms of the score, one will be much more higher. So let's say that if students are satisfied here, so we can determine that there's a strong correlation between the functionals and satisfaction here. So because the score is like more than 0.5. And loyalties also functional. So we can, based on this result, we can determine the functionals of the product, like I said, have a strong correlation between satisfaction and loyalty. So we need to focus on, as a marketers, we need to focus on, we can suggest marketers to, or the companies of a cosmetic company to focus on, especially in Malaysia, in terms of the functionalities of that product. So this we can recommend based on our results. And you look at this correlation, make sure that it doesn't, the correlation value shouldn't be more than 0.8. So kalau ada 0.8, if there's a value more than 0.8, that issues of multicollinearity. So multicollinearity, which is your the construct of your variable will be highly correlated with other. It's almost the same. Okay. So, but our main objective in terms of we look at the validity discriminant validity to make sure that the construct will be difference among other construct. That's for correlation. So once you have start with correlations, then we can test further in terms of to test the regression. Okay, so we can test regressions. Multiple regression is a statistical technique that permits the researcher to examine relationship between a single dependent variable saja. Okay, for SPSS satu saja dependent variable that we can test, but you can test several independent variables, and there are some assumptions that you need to look at. You need to look at the outliers. The outliers also can give an effect. Okay, if like the result of your data. And we look at normality, linearity, and homodicity, and multicollinearity. There's few options here that you can use for outliers, like using the basic one, that case-wise diagnostics, Mahal-Nobis distance, and also this curve ratio. So you look at the linearity. So this actually the circle is your respondent, okay. So you have your IB and DB, okay. So it's respond. So this in terms of linearity. Okay, multicollinearities. Previously, he suggested that the VIF shouldn't be more than 10, okay, and not to say it's a recent researchers that have suggested that the VIF variation inflation factor should be more than 5 or 3. So this is the all recommendation. So now we look at the should be more than 3 or 5. Okay. So ni kita mau tengok lah. Okay. More than VIF lah, more than this more than 5 lah. Okay, to test for the regression, okay, we need to know whether your hypothesis is a one-tail test or two-tail test. But normally for because we have already not performance, sorry, we have done our literature reviews, and then and we have like when we hypothesize, okay, that the relationship between your independent variable will be positive, okay, or it will be negative lah, okay. For example, like kalau negative, perceived risk will have a negative relationship with adoptions of cloud computing, for example, okay. And so for positive, so there will be your hypothesis should be a directional, okay. So when your hypothesis is directional, then you should use a one-tail test. So one-tail test, like a significant less than 0.05, significant level 5%, the t-value should be more than 1.65, and the significant more less than 0.01, okay, 1%, so that should be more than 2.33. And two-tail test is when we test like a mediator analysis, okay, and also correlation, okay, the Pearson correlation, then we use two-tail test. And if you hypothesize that there is a positive relationship, okay, so there will be, you are using a one-tail test lah. Tapi one-tail test is much more better lah, because like it will test, it will be the t-value will be less a bit compared to the two-tail test lah. Okay, for what is in terms of one-tail test, the rejection area is whether the upper or the lower tail lah. So positive and negative. A one-tail test is used when the hypothesis is directional lah. Okay, for example, whether it's a positive or there will be a negative relationship lah. Okay, Another thing that you need to know is the effect size when you look at the effect size of the relationship. One way that you can assess the importance of your finding will be to calculate effect size, the strength of association. So even for SPSS also result, you need to report this effect size. So effect size by using Cohen 1988, 0.02 is small, considered very small, and medium for this 0.15 and 0.3 large. Model of how to calculate the effect size. Okay, R square. R square is like how much of the variances that can be explained by how much of the variances in your dependent variable can be explained by the independent variables. But based on Chin's 1988, the R square are quite very high. Okay, if you look at the weak, 0.19 is considered to be weak. Moderate for 3.33 and substantial for 67. You can use Cohen R square to assess R square, like 0.02 is weak, 0.13 is moderate, and 0.26 is substantial. Okay, so when you test, just very quick, so I can go. Regressions, okay, click regression here. Sorry. So a very quick one here. So I will click independent here, and here satisfaction. So I will click linearity and so if you look at the R square here, about 44% of the variances can be explained by the predictors. So here, if you look at the result, here mentioned that it's significant, but for SPSS result, this significant level is actually based on the two-tail test. So what you guys need to do is to divide this, let's say, this significant value into two, because the result is based on two-tail test. Another way that you can look at the significant level is based on the t-values. So t-values more than 1 point be more, it will be considered significant. So here significant more than 1.65, and here more than 1.65. And the social, the t-value for social is less than 1.65. So social is not significantly related to satisfaction. So that's how we interpret it. Okay. So beta, you look at the beta score. Beta score, the higher the beta, the strength also in terms of the relationship between the independent and dependent variables. So here we can say that the functional has a strong relationship with the functional, okay, with the satisfaction. So we can suggest that we need to focus on the functionality of the product, and we can recommend to the companies and so on, okay, managers. So that's for SPSS. Let me do a quick one here. Okay, stratification model. It's a primary statistical model that seeks to explain the relationship among multiple variables. So it examines structures of interrelationship expressed in a series of equations similar with the multiple regression equations. SAM is a second generation multivariate data analysis method that is often used in research because you can test theoretically supported linear and additive causal models. So this by Chin's, Henelin, and Kaplan. And such a causal model is a combination of the thing that you I mentioned in the using the SPSS. The ability combination of the factor analysis, regression, reliability tests, everything lah in simultaneously. Okay. So, but compared to the first generation using the SPSS, you need to conduct it separately. Later on, I will show you that how this thing can produce. Okay, simultaneously lah. In a similar regression analysis, the difference between regression that we will test the equation at a time while use a structure model, the equation are tested simultaneously. So that's why your SPSS is the first generation, and the structure model is second generation analysis. So what is the difference between the first generation and the second generation? And we can look at here. So this is your independent X and Y, your dependent variables. So X will be measured based on X1, X2, X3. So that will be the proxy. So this X we call latent variable, Y is the latent variable, and Y1, Y2, Y3 is the observed variable. Yang mau ukur Y lah. Dan X1, X2, X3 akan mengukur the proxy of will be measuring the variable X lah. Okay, in the first generation analysis technique to analyze this relationship, macam tadi kan just now kan, we have to calculate that a score called X, or a mean score called X, and the score of Y. Okay, before we can run regression analysis. So this process to calculate the score is called summated scale. So to do this, like as I demonstrate just now, that using the mean score, okay, the average mean score, and we can use the total. Okay, total score is the sum score of the three items here. So so in the second generation analysis technique, we do not have to do this, as the model can be tested the way that we have drawn it. Okay, so directly by including the items and also the latent variables. So in the second generation analysis technique, we don't lose information. So kalau macam, for example, when we use the mean score, total score, we will lose information. So that's the drawback of like using this SPSS. Okay, there are two types of variation of SAM. Okay, statistical model. First one is the CB-SAM, the covariant-based SAM, okay, statistical model. The objective is to reproduce the theoretical covariant matrix without focusing on the expand variance. And the PLS-SAM, statistical model, PLS, the objective is to maximize the explained variance of the endogenous latent construct. So that will be the dependent variables. So let's look at the family of the CB-SAM. So CB-SAM, okay, like MOS, Bisrael, M+, okay. So that's the family software for CB-SAM. And the PLS-SAM family, like the Smart PLS, PLS GUI, Graph, okay. So among of this family, the most easier to use will be this Smart PLS lah. There's a free version like Smart PLS 2 is free, but there are some limitations of like that in terms of that we can use that software lah. And but still we can use it lah, okay, and it's free lah. Additional features lah, bukan that's not additional features that are not available in the second in the Smart PLS 2, whereas the Smart PLS 3 have several of the additional features that we can use to analyze our data lah. Okay, the most powerful for PLS SAM's software is the WAP PLS. WAP PLS is most powerful, but it's not really easy to use. Okay, so here are some of that argument for choosing a PLS. PLS makes fewer demands regarding sample size, but that's we cannot say that 80 or 90 or 100 of sample size that will be enough, okay, for to test, okay. So that's why like other researchers still maintain saying that it should be one item. You have to time 10, okay. For at least one item, this represents 10 respondents. So if you have like 30, so you should need to collect about 300. So that's for a sample size lah. At least to me, sample size should be more than 200. Should be fine, 180, 200. That when you consider as a small sample size lah. PLS does not require normal distributed data, but we can test. Okay, we can test whether your data will be in terms of the skewness and kurtosis. But when we use skewness and kurtosis for multivariate data analysis, the skewness should be plus minus 3, and kurtosis should be more than plus minus 20. Yeah? So that's how you analyze the skewness and the kurtosis. Okay. Apply the complex structure equation model with large numbers of construct. It can handle, okay, how huge of your relationship of the model, okay, how huge of your model. It can also it also can perform that generate the result. So PLS also can handle both reflective and formative construct, and PLS is better suited for for theory development than for theory testing. And we can use PLS for useful for prediction. So this is the benefits of using advantage of using partial least square. Okay. Before we start with there are two. When you perform such a question model, we need to follow recommended two-stage analytical procedures by Anderson and Gerbing. That is to test the measurement models, the validity and durability of the measures, and followed by the structured models. Once you have passed that the validity and durability, then you can proceed and the loading. So the loading should be more than at least 0.5. AVE should be more than 0.5, and the composite reliability should be more than 0.08. The discriminability, we can use Phonological and of course we can look at the cross-loading, and heterothread monothread. So all of this assessment, okay, need to pass, okay, before you can proceed for the structure models. So the structure model involve evaluating the R square, beta, and the t values, okay, the effect size, the predictive relevance, and so that's all that we will look at it. Okay. Assessing the reflective measure model. The goodness of measures. We have to assess, look at the indicator reliability, the loadings, and the average variance extracted, AB. Okay, and we need to look. We need to assess the Phonological Criterion, cross-loading, the heterothread, monothread, to examine the discriminant validity. Yeah. So the construct validity, you need to look at the factor loading, okay, variance extracted, and reliability, yeah, and discriminant validity. So okay, the composite reliability should be more than 0.7, 0.708. Combo alpha should be more than 0.7 also. The squared loading should be at least 0.5, but Chin require like more than 0.7. Okay, and but you can should be more than 0.5, and the AV should be more than 0.5. The average variance extracted. Okay, the discriminant, the Phonological Criterion, and the cross-loading, and the HTMT. Okay, so here are some of the issues that when we look at the combo alpha. Okay, in his book, here that okay, the composite reliability varies from 0 and 1, with higher values indicating higher level of reliability. It is generally interpreted that in the same way of combo alpha, reliability values 0.6 to 0.7 are acceptable in exploratory, but 0.7 and 0.9 can be in those research that has to be well established. Okay, values above 0.9 and definitely above 0.925 are not desirable because they indicate that all the indicators variables are measuring the same phenomenon and are therefore not likely to be valid measure of the construct. And but this actually being highlighted by here, but in other research, okay, our values of composite reliability and it can be more than 0.9, okay, it above 0.95 and so on. Okay, so let's look at the here stated that if the value is more than 0.9 and above 0.95, the composite reliability value occur if one uses a semantically redundant item by slightly rephrasing the very same question. So that's the issues of redundant items. So, but if your items are not redundant, okay, so there shouldn't be no issues in terms of when the values of the construct is more than 0.95. Okay, so here the forum that okay, I have reflected the model and there is issues with my measurement model. My composite reliability of some of the items about 0.95. So is that a problem? So we refer to John Michael Becker. Okay, thank you for your response. I'm asking this question because at the book of the book, okay, by here, the values are desirable. Values above 0.95 are not desirable because they indicate that all the indicator variables are measuring the same phenomenon, therefore unlikely to be valid measure of the construct. And here the responder. Well, you are here at the heart of the measurement theory. Taken as it is, the sentence is wrong. So you want all your items to measure the same phenomenon in a reflective model. Otherwise, you don't have a unidimensional construct. But practically, the authors point out the problem that often occurs in empirical research, where people use redundant items that are not adding any information about the construct. Here, for example, like, but only repeat the same aspect of the phenomenon. I like a product A, I like product A a lot. So this will be redundant lah. Okay. So sure, this measure likability, but surely could be also measured with a single item without losing information. So there's no issues of whether if your value, if items are not redundant like this kind of questionnaires. So you should maintain there's no issues of your the redundancy of your question. So you can cite this. Hold on. Okay, so that's combo alpha. So this okay, composability. Okay, composability should be more than 0.7, and indicator should be more than 0.5. Okay. Average variance extracted should be more than 0.5. Suggest adequate. So the discriminant validities, which is the extent to which the construct is truly distinct from the other construct by empirical standards. So to make sure that there is no overlap okay, of the construct. So kita boleh kasih membezakan lah kan, okay, in terms of discriminant validity lah. So traditional researchers have relied on we look at the cross-loading. Typically, the first approach to assess discriminant validity lah. So here we look at the cross-loading. So macam tadi juga SPSS kan, loading, and we look at the items of EV1 and cross with other items of with construct functional satisfaction symbolic. So higher, according to here, it should at least range between 0.1. So I minus 0.1 here. So the items shouldn't be more than 0.6. Here 0.704 with minus 1. So the item here can be more than 0.704. So this is how we look at the cross-loading. So if this, let's say that if the item here higher, like 0.68, like that, 0.68, then you need to delete, remove the items. So that will be cross-loading, to check cross-loading. So make sure that there's no item cross-loaded with each other. Okay. The phonological criterion, we use the square root of AVE. Okay. So square root of the AVE, and we will check on this is the square root of AVE. So make sure that the bigger than the rest of the correlation. Okay. So to make sure that to make sure the adequate of discriminant validity. Okay, but the two things that issues using this cross-loading and phonological criterion. Recent research that critically examined the performance of cross-loading and the phonological criterion for discriminant validity assessment has found that neither approach reliability detect discriminant validity. So Henseler proposed assessing the heterothread monothread HTMT of the correlation. So in short, HTMT is the ratio of the between thread correlation to within thread correlation, and HTMT is the mean of all correlation of the indicator across construct measuring different constructs. So we can for for PLS2, Smart PLS2, you don't have any option to test the HTMT lah. For Smart PLS3, it's available, okay, to test the HTMT. So that's the disadvantage of using Smart PLS2. Although it's free, but there's other features that is not available in the Smart PLS2 lah. So here HTMT, we need to check whether, as long as the correlation values, okay, shouldn't be more than 0.85 for if you are based on client, or shouldn't be more than 0.9, okay, based on goal. So let's say if the correlation here, if the value is more than 0.9 above, then there is a problem of issues of your discriminability. So, and in order to the remedies in order for you to decrease the value is to check the correlation, whether each items are highly correlated with the construct, for example, functional and satisfaction. Then you need to look at the item whether it's highly correlated, okay, with other construct. Actually, you can determine through the cross-loading, to this cross-loading, okay. But at the other time, then that even the cross-loading also cannot detect in terms of discriminability. So when HTMT detect, okay, if there's some issues of if the value of the if the value is more than 0.9 above, then you have to cross-check the items between this, let's say, for example, functional and satisfaction. Then you can test one by one whether remove one of the item can be solve the problem. Okay. Just a quick one, okay, for PLS. So even here I use so this is like this for Smart PLS3 . So if you look at the interface, kan juga quite very simple. You can calculate and then click PLS algorithm to test regression. Okay, just click bootstrapping. Okay, so I will try to do a quick one here lah. I thought I've already. So this like so for PLS3, I just can so this item proxy, I just can easily just click the shift button and drag. So you and just do this one as satisfaction. So this one I will have satisfaction. Now I'm using the student version, and the student version only allowed 100 sample. So that's the disadvantage of using this adalah student version. So dia ada dia punya limitation . So but for the if you have the license, okay, and you can the sample doesn't give you any issues lah. Yeah. So this error is depend on my so this is my independent variables and this is my dependent variables. So the error is based on my hypothesis lah. So I just click PLS algorithm. Okay, so this is the good things about this the smart PLS lah. So you can click on discriminability to check on the validity of that your data. Okay, constructability, yeah, and the R square here, effect size. Okay, so and the first of thing that I need to look at the auto loading. So here it's the green colors, score will show it's more than 0.7, but if it's less than 0.7, the color it put it in the red colors. So that's why it this like here's it shows that it's less than 0.7. So but I will use the cutoff 0.5 lah as for my loading score. So I will delete lah. Actually, we need to delete one by one, but straight away delete this every 5 and 6. So normally, but for bigger samples, I don't need to delete these items. So I go back here. So I click PLS algorithm. I'll go back here. Auto loading. So there's more than 0.5. Then I can check my AVE and my combo alpha. So if you look at here, the average extracted more than 0.5, okay, and the compositability more than 0.7, okay. So even the combo alpha also, it produced the combo alpha. So if you compare using the SPSS kan, kita terpaksa buat manually ya, one by one. We have to run it manually one by one. But if you are using this, the second generation kan, it just click, you just click and the result, it produce the result lah. Same goes like criminal validity, yeah. Okay, so that's the square root of AVE. So if you look at the square root for emotional, so it's more higher than the rest of the correlation, similar to functional, inspection, and also social. So next, look at the cross-loading. Okay, so check on the correlation. Okay, for example, like EB1 here is 0.858. So make sure that the item when you cross-checking it, it shouldn't be more than 0.758. Bila kita check cross. So And then once you already check cross-loading, and if there's issues, then we click on, we can check heterothread, monothread. So if you look at here, that there's no issues in terms of discriminability. Okay, there's no value more than 0.85 and 0.9. So that's why it's in green color. You have adequate of this convertibility. Loading also work fine here, and convergent validity, AVE compensability, and the discriminability is adequate. Then you can proceed for the structure model. Okay? Structure model, your hypothesis testing. Okay, you can check out the R square here. Okay, R square here about 39.9. The variances in satisfaction can be explained, okay, by this one. So this R square, inside R square here. Okay, so if you look at so this will be your the beta, okay, and this is the loading. We look at the loading here. So loading. Okay, loading, and then this the beta, okay, beta score, and beta is we can determine based on the strength of the relationship also. And if you look at here, it's the negative also beta, and in this circle, value represent the R square 39 point. So I just click here. It's the 39.9% of the R square. So being explained by the independent variables. So for okay, so for structure models, we need to perform bootstrapping. So bootstrapping is a procedure whereby a large number of subsample, like 5,000, say suggests of to subsamples at least 5,000 times. Are taken from the original sample, like let's say you have like 100 samples, so it will replace about 5,000 times. Okay, with the replacement to give a bootstrap standard error. So bootstrapping will generate the standard error, which in turn give the t values, okay, scores, whether significant or not significant. So the reason for this is that the character of PLSM is a distribution free. So as such as the standard errors used in the calculation of the t-value are calculated from the bootstrapping procedure. This is to avoid inflation or deflation of the standard errors due to non-normality. So to do this, we just click bootstrapping, and for example, like we just click calculate and then bootstrapping. So here I will subsample for 5,000, and I click one-tail test because my hypothesis is directional, positive relationship. So I click start calculation. Oh my God, almost stopped that. Okay, so this will be the result. So it provides the p-values, okay, the t-statistics, the t-value, standard error, and the beta. Okay, so this is the beta. So it shows here like the green color shows the significant. So function has a significant influence on satisfaction and symbolic. And if you compare the SPSS result, so it's like it actually is more similar because like the data that I use in the SPSS is about 583 data. So here I use 100 data, so that's why like this relationship is not significant. So, and you can confident intervals bias. So click on confident interval bias. You can determine that the lower level and the upper level. So make sure that there's no zero in between. Okay, for example, like negative 1.45 to 0.307, zero in between. So it shows that it's not significant. So if you look at the functional here, it's positive. Okay, and the upper level also positive. So there's no zero in between. So that shows that there will be a significant. So that's how you look at confident interval bias. To calculate the t-value, t-value is by taking the beta divided by the standard error here. You will get the t-values. Okay. And for example, here 0.442 divided by 0.089. So the t-value is around 4.96. So that's how we interpret okay, in terms of for hypothesis testing. Okay. So let's look at okay. If you want to report the effect size, you need to go back to your. So this is the t-value. Okay, this is the t-value of the relationship. And if you go back to your PLS algorithm to determine the VIF, you just click on the effect size. Okay, effect size will determine variables that are highly important. So kalau kita tengok sini, functional will be high effect, high impact and important. Okay, that we can that will lead to customer satisfaction. Okay, functionals benefits. And symbolic will be this will be what something moderate. Okay, moderate. So this is quite a bit high also. So we use effect size, okay, to determine the strength, okay, or the impact of that of the relationship. And you can suggest which one that's giving more important, and you can provide recommendation. The VIF, so you can determine here. So in terms of relationship, there's no value more than 3 and 5. So you are fine with the there's no multicollinearity issues. Okay. So another thing that that we need to test whether your model can be we look at the predictive relevance. So here we look at the Q2. Click blindfolding to check on. Okay, so make sure that your Q2 should be more than 0. Okay. So to show that your model can be predict. Okay. So by using looking at the Q2 here. Okay, 0.215 is above 0. So there is a predictive relevance for this study. Okay. So how to recommend when you have back here. So based on the proxy, and you have the proxy here for functionals and social. Okay, So let's say that if you want to suggest that marketers okay, try to or to communicate. Normally for marketers we have to develop like marketing communication. So we need to communicate the functionality of that of the products that will lead to satisfaction. So in order for you to suggest, okay, provide recommendation is through SILA, okay. So the item that you have, the question like FP1 to question 2, question 4. So that will be, you will recommend suggestion based on the items, your proxy, in order to improve function. So I think that's all that I can share you guys okay. Using SPSS and also using PLS
Thank you, Dr. Jud. I think you tried your absolute best to cram so many days of training into 2 short hours. Really some detail.
It's just we can do also like hands-on training we provided data, but for Smart PLS, Smart PLS 3, there's a free version for trial. Okay, there's a trial version that you can hold on, let me €200. But for 1 month, this is actually for academicians and students. For 1 month, you can purchase for 20 euro. So that costs about 9,200 ringgit .
Right. So okay, is it okay if I open for some a few questions and answer?
Yeah, just go ahead.
Yeah. Okay, so I open to the participants. If you have any questions that you'd like to ask, Dr. Jud. If not, maybe I start with the chat. I think we have a question from early on from Mr. Zakaria. His question, he asked, in stock market prediction, there are spike points, outliers for peaks and troughs. Is this kind of outlier can be processed or cleaned out?
It can clean up.
Can,
Yeah, you can clean up using the option here. Okay, let me show you a very quick one. You can click analyze and regression and linear. Okay, so here I can use the statistics, and then I click case wise. Case wise is plus minus 3 and also can use this the plot can use others like Harmonic of ratio. So this thing that you can use to detect outliers.
Okay, thank you very much. I hope that answers Zakaria's question. And then I think the rest are just requests for you to share your slides. So I hope you don't mind if you can email to me. I will share with the participants later.
Yeah, I can, yeah.
Thank you so much, Dr. Jud.
So, yeah, thank you for listening. Okay, although it's quite like here and there, because sitting down is like macam not like as good as kita doing demonstration, okay, hands-on work and so on, in the lab and so on. So I think, I don't know, you guys do also this kind of survey research like that?
Yes, I think many of our lecturers do a lot of this survey based on research based on surveys, so very helpful. So I hope you don't mind if some of them maybe will contact you for some assistance when they're actually doing hands-on with their work later on.
No problem, boleh lah.
Thank you so much, Dr. Jude. You're so kind. Okay, yeah. Thank you. Yeah, with that, I'd like to bring the session to a close. Thank you so much again on behalf of FKI. We are very grateful to Dr. Jude for this very insightful, very detailed and very valuable talk on statistical analysis for research. And thank you to all the participants for joining us today as well. So thank you so much again, everyone. Thank you, Dr. Jude. Goodbye and have a great day.
Thank you, everyone.
Thank you.